Hello and welcome back to Getting Started with BGFX. There are only 2 videos left in this series, and both of them are to do with drawing text to the screen. So in this first video we are going to be creating something called a font atlas texture. So this is a texture that exists in memory, and it has one of every character that you could want to render to the screen to write some text to the screen. So we need one of every character on our keyboard. That's upper and lowercase letters, all the numbers and all the characters. And then you render one of those into the texture. So you take your font, you take the font size, and you render one of every one of those characters to the texture. And from there you can just use that texture as an ordinary texture. So drawing text to the screen from there is just as simple as looking up all the metrics that you want for that particular character and then choosing the right region from that texture. Alright, so without any further ado, let's dive right in. Now before we get into the code, it's useful to have a look at the different metrics that are associated with each character, or glyph as they're known. So this little dot here, this is the origin point for this particular glyph, and this bearing X and bearing Y are the distance from the origin in pixels of the top left of the glyph. And then we have the width and the height of the glyph itself, and then we got this advanced width. So this is the distance in pixels from the origin point of this glyph to the origin point of the next glyph, so that it can be used as what's called proportionally spaced font. So this lowercase g will be larger than, say, a lowercase l, which is narrower. So the advanced width would be narrower, and the origin point of the next glyph will be closer to the origin point of this. So the advanced width gives us the distance from the origin point of our glyph to the origin point of the next glyph. So we need to know those sorts of things so that we can draw them correctly. Alright, so let's get into our code. Okay, first we need to include the free type header. So we go into our renderer header, and we'll go up to the top and we'll include ft2build.h, and then we need to define ft underscore free type underscore h. Now we need to define a structure which has all the metrics for each character, or glyph as they're known, and so that we don't have to calculate each time, so that we will so that we can store all these for each glyph. So we'll go struct glyph metrics. Now the first thing is glm ivec2 offset. So this is the distance in pixels of the top left of the glyph from its origin point. Then we'll do another one, ivec2 dimensions. This is the width and height. Then we'll do int32 underscore t advanced width. So that's the distance in pixels to the next origin point of the next glyph. Then we'll do glm vec2 texture coordinates 0 and glm vec2 texture coordinates 1, and that's meant to be coordinates 0. So texture coordinates 0 and 1 are the start and end texture coordinates of the glyph within the structure. Okay, so now we create a function that creates the font texture. So we'll go down here, we'll still just make it public, it doesn't matter. So void create font texture. And now we need a bunch of variables. So we need to store the free type library, the font face, the texture, and we need an unordered map for all the different glyph metrics. So we'll just do that at the bottom here. So drop a couple of lines. We'll go ft underscore library m underscore free type library. And then we'll go ft underscore face m underscore font face. Why are those red? Oh, I'm sorry, it's meant to be include ft underscore free type underscore h. Okay, now that we've done that, so now we need to create, we have a texture handle, BGFX texture handle, m underscore font texture. And we'll have an unordered map. So we'll go up here. Unordered map. So we'll go std unordered map. And it's going to be char as the key and glyph metrics. M underscore glyph metrics. Okay, now we've got the variable set up, so now we need to initialize our library. So we go up to the top here, go into our initialize function. So I'll just do this at the bottom here. So first we go ft underscore init underscore free type, then we give it the pointer to our library. Free type library. Then we open up our font, ft underscore new underscore face, m underscore free type library, and our one's called January night.ttf true type font. Face index, not sure what that is, I just set it to 0, and we give it to the pointer to the variable that we want to store it in, so font face. Okay, then we call our create font texture function. So there are 95 glyphs that we need to render, including the space, and 95 is close to 100, so I broke them up into 10 rows of almost all 10. Last row will be 5, obviously. First, we need to determine the size of the texture that we need. Now the simplest way to go is to go through all the glyphs, find the dimensions of the largest glyph, and make the dimensions of the texture 10 times the width and the height of the largest one. This would guarantee that the texture is large enough, but it would end up with a lot of empty space and wasted data. So what we are going to do is we are going to go through each row of 10 and find the maximum width. And at the same time we'll find the maximum height and multiply it by 10. So we'll just go here and we'll create this function. Now first thing is we need a string to contain all of the characters that we will need. I won't bore you with this, I'll pause the video, but what I'll do is I'll just press every key on the keyboard, then hold down shift and press every key again. There we are. So now we need to set the character size. So we go ft underscore set underscore char size, open bracket, we give it the font, m underscore font face. Then we need to give it the width. So these are given in fractions of a pixel. So we just go 100, then multiply by 64. And char height, we don't need to give it anything. And char width don't need char height don't need to give it anything. Then 96 for the resolution. I'm not really sure what that is, but it just works for me. And then 0 for the last one, and that's meant to be a comma, not a dot. Okay, now we go uint 32 underscore t max width equals 0, max height equals 0, and the row width equals 0. Then we'll go through start index equals 0, index is less than text to render dot length index plus plus. So if index is greater than 0 and index percentage 10 equals 0, that means we've just done a row of 10, so we need to set the max width equal std max of max width and this row width. And then we need to set row width back to 0 because we're starting a new row. Okay, so now we need to find our all the different width and height and all different metrics of this particular glyph. So we go ft underscore u int glyph index equals ft underscore get underscore char underscore index. Then we give it the font face, m underscore font face. Then we give it the character, so we go text to render of index. Okay, so that just gives us the index of the glyph inside this font. Now we need to load it. ft underscore load underscore glyph, open bracket, m underscore font face. Then we give it the glyph index, and we don't have any flags. Then we need to go max height equals std max of max height, and then m underscore font face glyph. So this is the glyph that we've just loaded. Bitmap dot rows. This will give us the height in pixels. And now we go row width plus equals m underscore font face glyph bitmap dot width. So that's the width in pixels. So what they'll do is that it will give us the maximum height of whatever of the rows, and it'll give us the width of the largest row. So that we can use that to create the width and height of our texture. So we go u int 32 total width equals max width, and then u int 32 total height equals max height times 10. Okay, so that'll be the width and height of our font atlas texture. So now we need to create the image data. So the image for the glyph from FreeType is a bitmap with 1 byte per pixel. So we are going to fill the texture with transparent white and use the byte from FreeType to control the transparency. I don't know if there's a better way of doing this, but I've used this and it works pretty well for me. So we'll create a vector of uint 32 underscore t, call this image data, then we'll resize it, total width and total height, multiply it, and now we'll fill it. So we'll call std fill, open bracket, image data dot begin, image data dot end, and we'll go 0x 0, 0, so that's the alpha channel, so it's going to be completely transparent. Then blue, green, red. Okay, so transparent white. Now that we've created the texture, we are going to go through all the glyphs again and get all the metrics that we need and set the image data. So first we need a couple of offsets. So we go uint 32 underscore t x offset equals 0, uint 32 underscore t y offset equals 0. Then we'll do the same thing we did above. We'll go through all the characters equals 0. Index is less than text to render dot length index plus plus. Now if index is greater than 0 and index percentage 10 equals 0, that means we're up to the 10th or 20th or 30th character. So the y offset plus equals max height. So we're moving down to the next row, and we'll set the x offset to equal to 0 so that it goes back to the beginning of the row. Then we'll load everything again. So do what we've done above. We'll load the glyph index and then load the glyph, and then we will need to render the glyph. So uint int glyph index equals ft underscore get underscore char index. Give it the font face. Then text to render of index. Then we'll load the glyph. So annoying how if you go back, the IntelliSense just breaks down. I don't know why. M underscore font face, glyph index, and no flags. Now we need to render the glyph, so ft underscore render glyph, m underscore font face, glyph, and we give it a flag of render mode normal. Alright, now we need to set all of our font metrics, so all of our glyph metrics. So we go glyph metrics, and we'll get a reference to it. Glyph metrics equals m underscore glyph metrics text to render of index. So we'll set the offsets first. So glyph metrics dot offset dot x equals m underscore font face glyph bitmap left, and then we'll just copy that. Offset y bitmap top. So those are that's the bearing x and the bearing y, so they'll give us the distance in pixels from the origin to the top left of our glyph. Now we need to set the dimensions. M underscore font face glyph bitmap dot width, and we'll set the y bitmap dot rows. Now we'll set the advanced width. M underscore font face glyph advance.x. Now we need to shift it to the right 6. That's because the advance is given in terms of fractions of a pixel, so it's in what's called 26.6 pixel numbering format. So that's the rightmost 6 pixels, so the 6 least significant bits give us the fraction of pixel that the advanced width is, and the 26 most significant bits give us the actual number of pixels. So we're not interested in those 6 bits that give us a fraction of a pixel, so we can just shift this to the right 6 and they'll get rid of it, and they'll just give us the number of actual pixels which we are interested in. Okay, so now what we need to do is we need to set our texture coordinates. So remember, texture coordinates are given in 0 and 1. So we go glyph metrics dot texture coordinates 0, and we'll go dot x equals, we'll convert this to a float, x offset divided by, and we'll do float total width. Okay, so x offset is the x origin of this glyph within the texture, and total width is the total width of our image. So we need to divide x offset by total width so that it's normalized, so it's between 0 and 1. Okay, now we need to do the y. So it's very similar, so we can just copy it. And we go y of y offset divided by total height. Okay, now the texture coordinates, the bottom right, so texture coordinates 1 is, they start off at these texture coordinates, and then we need to work out the width and the height of this glyph, and then normalize those metrics, and then add it to the top left. So add it to 0. So we'll go glyph metrics dot texture coordinates 1 dot x equals glyph metrics dot texture coordinates 0 dot x plus, then we can just get the dimensions here. So first we need to convert that to a float, and then divide it by float total width. Okay, and then it's the same thing for the other one. So for the y, go y, and that is the total height. Okay, so that is the texture coordinates. And now we need to go through all of the pixels within this glyph, and we need to set the right pixel in our image data. So first we'll go for uint32 underscore t, y equals 0, y is less than m underscore font face, glyph bitmap dot rows y plus plus, and then we can do the same thing in here, just copy that, then change that to x, and then width, and then x. Alright, now inside here we'll go image data, open bracket, y plus y offset times total width plus x offset plus x. So y offset and x offset are the offsets within the texture that this glyph will start. So we'll just add on to the y of this particular glyph, multiply by total width, so that'll give us the y position, and then add on the x offset and then the x. Okay, so now what we'll do is we will OR it with the pixel from the glyph. So we go OR equals uint 32 underscore t m underscore font face glyph bitmap dot buffer and then y times m underscore font face glyph bitmap dot width plus x, and then we need to shift it to the left 24 bits. Reason we do that is because this buffer here is only an unsigned char, so it's only 8 bits wide, and we need to occupy, if we just OR it like that without shifting it, it will just occupy the rightmost or least significant bits, which we don't want because that's the red color. So we need to shift it all the way to the left so that it occupies these bits here. Okay, now that we've done that, we can create the font texture itself. So we go out here, m underscore font texture equals BGFX create texture 2D, open bracket, then we go uint 16 underscore t total width, then the total height, no mipmaps. I actually just recently learned what mipmaps are from a very useful comment. Thank you very much for that. Only one layer. Give it the format. Texture format. RGBA8. Then we need to give it the sampler. So it's BGFX sampler. Point. Then we tell it to clamp it if it goes beyond the edges of our texture. So BGFX underscore sampler underscore UVW underscore clamp. And now we can copy in our data. So we go BGFX copy image data dot data total width times total height times 4. Okay, so now that we've done that, we've created the texture. We can't actually see it yet. We can't see any text, but what we can do is we will write this to a file so that we can open it and we can see what all the different glyphs look like. So we will go up here and we'll define stbi underscore msc underscore secure underscore crt, just to get rid of those annoying errors. Then we define stb underscore image underscore write underscore implementation. Yep, spelled that right. And then we go include stb underscore image underscore right. So we'll scroll down to the bottom here. So we can write this to a PNG. So we go stb underscore image, stbi underscore right underscore PNG. Then we give it the name. We give it the width. So total width, total height. Then 4 color channels, image data, and we need to give it the stride in bytes, so that's how wide each row of the image is. So it's total width multiplied by 4 bytes per pixel. Alright, let's build that and we'll see what we get out of this thing. Yep, this is one of those annoying warnings, so I'll just go up to the top here and we can just define that. Define underscore CRT underscore secure underscore no underscore warnings, because we know this is going to be fine. Okay, apparently I still didn't like that, so what we'll do is we'll copy that, right click on the project, go to properties, go to C++, preprocessor, make sure we're in the right one, so we're in debug, and we'll just add this. Okay. Alright, let's rebuild this. And just looking at my example, I just saw that I missed a line, so at the end of this main loop where we create the glyphs, we'll go x offset plus equals m underscore font face glyph bitmap dot width. Alright, we'll build that. And nothing's changed here, but if we go to our project folder, you can see text.png has been created. So we'll open that. And here's all of our beautiful glyphs. So this is one of every character. And as you can see, we can just use this as a normal texture. So if we want to render this breaker, for example, we just get the texture coordinates, render from there down to there. And we've got all the metrics we need to make it all nicely proportional, like you can see here. And that's it for this video. I will push everything to GitHub. We've only got one more video left in this series, and we're going to make a function that uses our font atlas texture to draw whatever text we want to the screen in whatever color we want. So I will see you there.